Hi, I am Siti Rauda Fatina Narimani from 11 Cambridge 1. So today I would like to show you how to do some questions on physics about temperature and heat and kinetic theory of gas. So here we go, the first question. A Carnot machine is operated between two heat reservoirs. Each temperature are T1 and T2 with T2 is bigger than T1. The efficiency of the machine is 40% when the T1 equals to 27 degrees Celsius. Calculate the temperature change needed to increase the efficiency. So we know that we are going to calculate the temperature change if its efficiency is 60%. First, we should remember that T2 is bigger than T1. So, the formula is mu1 equals to, in the bracket, 1 minus T1 per T2. We substitute the number into the formula, so it becomes 40% equals to 1 minus 27 degrees Celsius per T2. We can change the 40% into 0.4. And the 27 degrees Celsius, we can convert that into Kelvin, so it becomes 300 Kelvin. (0.4) equals to, in the bracket, 1 minus 300 per T2. So the T2 is 500 Kelvin. Now we're gonna find the T2 if the efficiency is different. So we change it into 60% equals to, in the bracket, 1 minus 27 degrees Celsius per T2. 0.6 equals to 1 minus 300 per T2. So the T2 is 750 Kelvin. To calculate the temperature change, we're gonna subtract the T2 with T1. So, 750 Kelvin minus 500 Kelvin equals to 250 Kelvin. So the temperature change is 250 Kelvin. Now for the second question. An electrical heater, which has resistance R, uses a voltage source of 10 volt. The heater is used to heat 1 liter of water from 10 degrees Celsius to 70 degrees Celsius. If 70% of heat produced is taken by the water, then the time required is T seconds. If the heat produced is 80%, then the time required is. So in this question, we're gonna find the time required if the heat produced is 80%. Based on the question, here we're gonna use the formula that watt equals to heat. So that the formula becomes percent times V squared per R times T equals to MC delta T. Here the percent as the percent of heat produced that is taken by the water. The V is the voltage per R, that R is the resistance, T is the time, M here as the mass, C here as the specific heat of the water, and the delta T is the temperature change. So T equals to MC delta T times R per percent V squared. We substitute the number, so T becomes 1 times 4,200, it's from the specific heat of water, times 70 minus 10, times R per 70%, so it becomes 70 per 100, times 100. So we already got the T if the heat taken is 70%. Now if the heat taken is 80%. The formula is still the same, but we change the number into 70%. T2 equals to 1 times 4,200 times 70 minus 10 equals to R per 80 per 100 times 100. T2 equals to 3150 R. So, the time required is 7 per 80. Done! Now for the third question is about kinetic theory of gas. The pressure of gas in a container with 100 centimeter cubic volume is 200 kilopascal, and the translation kinetic energy for each particle is 6.0 times 10 to the power of minus 21 joule. The number of gas particles in the container is... First, we're going to convert that into SI, so 100 centimeter cubic become 10 to the power of minus 4 meter cubic. 200 kilopascal become 2 times 10 to the power of 5 Newton per meter square. So the formula is N equals to 3 per 2 times PV per kinetic energy. N equals to 3 per 2 times in the bracket 2 times 10 to the power of 5 times 10 to the power of minus 4 per 6.0 times 10 to the power of minus 21. N equals to 30 per 6.0 times 10 to the power of minus 21. So the result is 5 times 10 to the power of minus 21.